Hey, fifth graders. All right, so this is going to be lesson 16 of getting ready for math. It's on GR 37 is where it starts. And we are going to be finding area of, well, really we're going to find area of parallelograms, but of shapes that maybe you're not used to finding the area of. So this works really nice on parallelograms. It works not so nice on other things. But parallelograms, because rectangles are parallelograms, rectangles and squares are parallelograms, you can still use that base times height formula. So if we think about it, and this is going to be just terrible. I apologize for the shoddiness of my drawing, but it is what it is. So here we have our parallelogram, okay? Now, it's just terrible. That's a little better. Okay, now in order for this line and this line to be parallel, that means that these two lines actually have to be equal to each other. Okay, and in order for these two lines to be parallel, that means that these two lines have to be equal to each other. Now they don't have to be equal to the ones that they're connected to, but they have to be equal to the ones that they're parallel to. It's just kind of how it works. So hopefully when you guys have this blown up on a screen, it'll be bigger than it looks on my computer right now, but that's okay. So since this line is equal to this line and it's also at the exact same angle, we can actually move, if we were to cut a portion of this off and scoot it over here, this line and this line could sit right on top of each other. And we can use that. Let's say that this is, I don't know, we'll say 12. And we can use this by saying, okay, if that's 12, and if we run a perpendicular line straight up here, okay, and this is, I don't know, we'll say 7. Let's use units. Okay, so 12 inches here, 7 inches up. Okay, so our height is 7. Now, that means that over here, going straight up again, this is also 7 inches. And I could cut this little triangle off, and I could transport it over here, and it would sit right on top of it and turn this into a rectangle. Now again, our base of 12 has stayed the same, okay? Our bottom number has stayed the same. Now we have a height here, and this distance here is actually equal to this distance here. These triangles that I've formed are congruent, they're equal to each other. So I can just move this shape over here, kind of get rid of it over here, and now I just have a nice pretty rectangle. Ignore that there, okay? That is 12 inches on the bottom, and it goes 7 inches up and down. So to find this, I just say area equals base times height. That means that area equals 12 times 7, which is 84 inches squared. Now, this works on parallelograms, okay? And obviously it works on rectangles. You just don't have to do the cutting a part off and moving it around or anything like that. It does not work on all quadrilaterals. It'd be really fun if it did, but you got to remember that you can have quadrilaterals that look like that. That is a quadrilateral, right? Assuming that those are actually connected. You've got 1, 2, 3, 4 points here. Well, we're not going to find a base and a height and say that that is, multiply those two together. That's not how that works. If you want to know how to figure out the area of all quadrilaterals, it involves some different math that we're not quite ready for, basically. Okay, so base times height is what you want to do. Fortunately, and it does a pretty good job of explaining this to you, but fortunately, for the most part, this lesson is very straightforward. They're going to give you two numbers, and you're going to multiply them together. That's as hard as it gets. Let's look at a couple of them. So we'll do let's say number 6 here, which is kind of like this, and something like that. And it's got this little thing coming down here, and it's got the box, which means that's a 90-degree angle. This is 2.5 centimeters, and this is 11.3 centimeters. I remember why I said that, or why I picked this one to do. Okay, hopefully you can see that through the glare. Anyway, the reason why I picked this is because they are going to start having you multiplying decimals, and you might not remember how to do that just because it's been a little while since we did that. So this is going to be 2.5 times 11.3. 11.3 times 2.5. Now, the big thing to remember here is when we multiply with decimals, ignore the decimal point to start with, okay? Just solve the problem as if it was 113 times 25. Okay, so 5 times 3 is 15, carry our 1, 5 times 1 is 5, plus 1 is 6. 5 times 1 here is 5. Then we're gonna go a 0, and then 2 times 3 is 6, and 2 times 11 is 22, but 2 times 2, yeah. And then we add them up, okay? So far, pretty easy. You guys should all remember how to do this, hopefully. That's gonna be an 8 and a 2. Okay, now, at this stage, we have to do a little bit of, well, not a little bit of anything. Now we go back up to our original problem, and we say, how many numbers are to the right of the decimal in our original problem? Well, we've got 1 here, and we have 1 here. So we've got 2 that are to the right of the decimal. That means you need to move this decimal point over 2 spots to the left so that you have 2 numbers to the right of the decimal in your answer, okay? So your answer is going to be 28.25. And if you kind of think about it, we can sort of estimate, we say, well, this is, 2.5 is right between 2 and 3, right? And 11.3, that's kind of close to 10. So our answer, if we rounded this down to 2 and multiplied it times 10, that'd be 20. If we rounded it to 3 and multiplied it times 10, that's 30. So it's going to be somewhere between 20 and 30, but we know that this is really 2.5 times 11, so it's going to be much closer to 30 than it is to 20, right? So just sort of as a way of estimating this. And from there we could say, well, 28.25 makes sense. If you didn't have that decimal point there, 2,825, that sure doesn't make sense. If you had it at 282.5, that doesn't make sense. And if you had it at 2.825, that doesn't make sense since 2 times 11 is 22 already, okay? So this 28, that's the only one that really makes sense. So I know that a lot of you guys tended to grumble and roll your eyes and groan when I would make you do the doing estimates and just telling you like, hey, just do a quick estimate to figure this out. Well, doing a quick estimate can kind of tell you where that decimal point should be, right? 2 times 11 is 22. That means your answer is going to be somewhere probably in the 20s or the 30s. It's definitely not in the hundreds, and it's definitely not in the ones. So putting that decimal point shouldn't be too hard. Okay, the other one that I was going to do is, let's do number 9, just to give you kind of a refresher on multiplying fractions. So number 9, and let's switch colors so that this is a little darker. Sorry, low enough, good. Okay, so number 9 says that the base is 1/2 foot, and the height is 3/8 of a foot. And then they want you to tell what is the area. Okay, so all you're going to do is multiply 1/2 times 3/8. Straightforward, right? So if you have forgotten, all you do is go straight across. 2 times 8 is 16. 1 times 3 is 3. So your answer is 3/16, since we can't simplify that, feet squared. All right. So just remember, when you multiply fractions, only when you multiply fractions, you just go straight across. You don't have to find common denominators. You don't have to do any of that stuff. Just straight across. Top times top, bottom times bottom. Easy. And yeah, that should be about it. So again, as always, good luck. If you have any questions or anything like that, just let me know. I'll be happy to help. But hopefully this is a pretty straightforward and pretty easy lesson. So, all right, talk to you later.